So how do we find the maximum minimums of sine and cosine graphs? Well, what I'm hoping you remember from what you've studied so far is that the sine, so if I'm talking about trying to find trig values off of the unit circle, which is the one easy way to do that, if I've got an angle of pi over 6 or 30 degrees, I look at the opposite side to get the sine, because remember this is the unit circle. So, and if you remember SOHCAHTOA, right? The sine is the same as the opposite over the hypotenuse, and if the hypotenuse is 1, the sine is the same thing as the opposite side. And since the opposite side is the y coordinate, that's how it is there. The sine is the same thing as the y. The cosine is the same thing as the x. So if I have to figure out what the maximum minimum values of 2 sine x are, well, I just got to look at the turning points. So if I look at the y coordinates of 0 degrees or 0 radians, I look at the y coordinate, I see 0, so I know the sine graph is at 0. And then if I look at, I can graph all those y values if I want, but it's easier to look at pi over 2, 90 degrees. I look at that y value, it's going to be 1 here, but since this has an amplitude of 2, I know this has been stretched vertically by a factor of 2. So I'm going to mark out my turning points on here. So 2 pi, 1 pi is halfway around, half of that is pi over 2, and then 1 pi over 2, 2 pi over 2, 3 pi over 2. And I just said at 3 pi over 2, I know that this graph maxes out at 2, and then it starts coming down. The y values, now remember, sine is graphing the y's, so it's at a maximum at pi over 2, and then it starts decreasing until pi. So then at pi it's 0, because that y coordinate is 0, and then it turns negative, because all these have negative y values, until it bottoms out at negative 3 pi over 2, since the sine is the y value. Since the sine is the y value, it's negative 1, and 2 times negative 1 is negative 2, and that's why I'm put that point way down here at negative 2, not negative 3, sorry. And then I'm back up here at 0, because when it swings back around, it's 0. So here's the graph of the sine function, and that has a maximum value of 2. So those maximums are happening at pi over 2, and the minimums happening at 3 pi over 2. And then if I wanted to go again, well, it would be coming back up here, and that's going to be 2 pi radians away, because I've gone to here, and then I've got to go all the way back around the circle again. And for this graph, for this function, that period is 2 pi, right? So the maximums happen at pi over 2, at, what is that, 5 pi over 2. Then I have to add 2 pi again, which is the same as plus, maybe I better do that. 4 pi over 2 is the same as 2 pi, so I added 4 pi over 2 to 1 pi over 2, got 5 pi over 2. I'd have to add 4 pi over 2 again, so the next maximum would happen at 9 pi over 2. And the minimums work the same way, except I'm starting at 3 pi over 2. Okay, so that's the sine graph. Let me do a cosine graph for you. So I know cosine is the same thing as adjacent over hypotenuse, and if this is 1, if the hypotenuse is 1, because this is on the unit circle, that's the same thing as the x value over 1. So for 0 degrees or 0 radians, I'm looking at that x value is 1, so cosine of 0 is 1 times 3 is 3, so it starts here. Then I could keep graphing all those x values and multiply them by 3, of course. Then I'm going to get to pi over 2. I'm seeing the x value is 0. 3 times 0 is 0. Then I'm down here, same thing. X's are negative, so I know I'm going to have negative y values, or negative values on the y-axis. Then I come to pi. The x coordinate is negative 1. The cosine of pi is the same as negative 1. 3 times negative 1 is negative 3. Then I'm back to 0. I'm back to 1. And there's one cycle of this graph. And I could keep it up, but I know in order to get back here to x equals positive 1, I'm going to have to go over 2 pi units. So, because that's the period of this graph. So the maximums happen at 0, at 2 pi, at 4 pi, etc. If I was talking about the minimums, well, those are happening in pi. And then I'm going to add 2 pi to that, so that's 3 pi. I'm going to add 2 pi to that, and that's going to be 5 pi. And that's how you deal with this. And all you got to really worry about is that amplitude. And then, of course, when they start doing other kinds of shifts, that's another whole thing. But this should help you get through that question.